All right. All right, well, good afternoon, everyone. I'm Colin Dembovsky. I'm the Director of Field Services for GitHub Copilot. So it's a really fancy title, but I come from the solution engineering world at GitHub, and been with GitHub for about 4 years. I have an app development background before that, and spent a few years in DevOps consulting, so helping software teams adopt Agile and Azure DevOps. Spent many, many years of my career with Azure DevOps. But I now work for GitHub and took on this new role about 6 months ago, focusing totally on Copilots. So anyone here hoping that this is a talk about Copilots? Anyone? Okay, so this is not a talk about Copilot, although we'll talk a little bit about how Copilot is affected by this. But yeah, I spend most of my time talking to customers about Copilot and taking feedback from customers and partners to the product team and trying to help the product team convey the message of what GitHub is building. So we'll see a little bit of that today as we go through this. So I'll start off with a few slides, and then I'll go and show some stuff. But here, show by hands. Can I ask for a show of hands? Who's on GitHub today at work? All right. Who's using GitHub Advanced Security? Okay, a couple hands. All right. Okay, so this is good then. All right, because I think you'll see some stuff that probably you don't really know about. But I wanted to start off with kind of 3 core themes. We're 2 weeks away from GitHub Universe, which is our annual conference, is in 2 weeks' time in San Francisco. So there's a lot of announcements that are coming out there, which unfortunately I can't talk about today. So I may hint at a few things today. But you'll see these 3 pillars pretty heavily at GitHub Universe in 2 weeks' time. We're building very heavily for an agentic platform, enabling agents to work in the background, to complete work for you, to complete work multi-threaded. We're still very focused on developer experience, being able to give editor choice, being able to give model choice, being able to make AI workflows smooth for the developer. And then that 3rd pillar, which is what we'll talk about today, is the integrity and trust, right? And so, a couple of talks I've been to today have spoken about how how do we actually get from vibe programming into production. So that'll be my talk tomorrow, where I'll give some tips and tricks on the Copilot side of how to actually vibe code into production. But if we don't trust the code, and we should always trust but verify, then we can't actually gain the speed of these AI tools because we don't want to produce insecure code. So the integrity and trust is an important pillar for us. So we'll dive into that today. Anyone here never pushed a secret to their repos? Okay, you're lying. All right. It's so easy to push a secret to your repos. But we do have push protection. Again, I'll show a little bit about how we handle secrets and how we think about secrets. But secrets, you can have the most secure app on the planet, and then you leak a secret in your repo, and now you're hacked, right? So secrets it's important to make sure we've got mechanisms for that. It's important that we figure out how to use secrets effectively when we're using GitHub Copilot and other AI tools. All right, and then, again, I don't want to spend too much time on this, but traditional application security processes break the developer flow, all right? So when I was a developer, back in the day, the only thing I knew about security was they were the people that blocked you from going to production, all right? That was my entire experience of security. I didn't want to deal with the PDFs of all the scan reports they gave me, because I was like, I'm delivering features. I don't care about fixing security vulnerabilities or upgrading dependencies, right? So traditional application security workflows don't really work for modern application development. They can slow down the team. They can end up diluting all of the benefits from using tools like GitHub Copilot. So we do have a solution for that with GitHub Advanced Security and with what we're building into the platform. So I want to talk about a couple of things today. So we'll see some AI-based remediation. So what happens when you do get a security vulnerability? How does a developer who's not a security professional actually go around fixing that? Actually, I'll go back to this slide here. Anyone here a security professional? That's what you do day in and day out. Okay, so we've got one in a room of about maybe 20 people, right? So we're still better than the 1 to 100 ratio that's kind of typical for the industry, right? But I had a customer, it was an automotive manufacturing customer. So I spent a lot of my time at GitHub managing some automotive customers. So this particular team, they had about 3,500 developers in their US offices, and they had one security professional. So I had this one gal, she was the security gal for 3,500 developers, right? So how do you then do security at scale, right? It's fine if you can do security at one repo, but how do you manage it for hundreds or even thousands of repos? How do you manage it for dozens or hundreds of teams? So being able to manage and do security at scale is actually a non-trivial exercise. And again, I'll show you how we handle that in the GitHub world. So we're going to talk about management at scale, and that's going to let you actually take advantage of all this development velocity. It's built into the flow, so developers are not going to feel like it's an undue burden. They're going to be able to still do vibe coding, and they're still going to be able to use Copilot, but they're going to be able to produce much more secure results. Again, we'll talk about some of these things like securing supply chain with attestations. Anyone here using build attestations yet? Okay, we've got one hand there. Okay, so we'll show some of that. Enterprise visibility and control. I know Barbara was asking about, are we going to see some enterprise stuff? So we'll see at the enterprise level how we can get visibility into what's going on. So again, trying to think of that one security professional who's managing hundreds of teams. How do you actually see what's going on at that enterprise scale? And then, building CodeQL, which is our scanning tool, into every PR, auto-fix for AI-assisted remediations, secret scanning, push protection. These are all the mechanisms for actually keeping your CISO happy while you're vibe coding, all right? So then, again, just some stats here. We've got security campaigns. All right, so I was chatting to some folks over lunch, and we were talking about how, let's say that you turn on Advanced Security and you get 10,000 alerts across all of your repos. All right, now, how are you going to burn down those 10,000 alerts? All right, you can't just send an email to your developers to say, please burn down the results. You've got to have some kind of systematic and programmatic way of actually prioritizing which of those alerts are the most important ones you want your teams to focus on, and actually burn down that security debt in a very systematic way. So anyone using campaigns? Okay, great. So you're going to see some stuff today that's in the platform already that you can start using, but we'll talk about campaigns and how that helps. I mentioned build attestation, so how can you make sure that the binaries that are coming out of your builds haven't been tampered with? So that's build attestation. I'll do a very light demo on that so you can see what it looks like, but we won't dive too deeply into that. It's actually pretty easy to get it in there, but if you've ever tried to do any build attestation, you have to set up a SIG store and certificate signing, and there's a whole lot of things that you need to go through. We just make it easy by adding an action into your workflow, and then you can use the GitHub CLI to do the attestation. We've got a Kubernetes controller as well that will verify containers, for example, so that your Kubernetes clusters are validating that the images are actually attested and built without being tampered before they admit them. So we've got an admissions controller for Kubernetes, so that will help with that. Right, and then built for enterprise scale. So I've talked a little bit about ease of setup. Again, even if you've got a security tool like a Veracode or a Fortify or a Checkmarks, again, how do you get that out to 10,000 developers, right? It can take a very long time to get good security coverage. We actually do it with one click, essentially, and you have full coverage over all of your repos and for all of your teams. So the ease of setup, simple to scale, and then have those enterprise controls. All right. I'm going to get to the end of my deck, and then we'll go into some demos, but I want to just talk about two concepts that are really important with GitHub Advanced Security, and we talk about these internally. We talk about get clean and stay clean. All right, so again, most of you have code that already exists, and so there might be existing repos, and you're going to turn on the detections, and it's going to find a whole bunch of findings, right? And at some point, you're going to have to burn down those findings, right? So that's the kind of the get clean, right? How do I actually take my existing security backlog and start burning that down? But then on the stay clean side, it's like, okay, we don't want to add any more vulnerabilities, right? So while we're burning down the security backlog on the one side, we want to make sure that we're not introducing more vulnerabilities for development that continues, right? So get clean is about things like security configurations and rule sets. How do we put the right gates in place so that every PR that's coming in has scans that we're able to fix those and make sure that we don't introduce more vulnerabilities. I'll talk a little bit about Copilot code review. And then get clean is, okay, for our existing backlog, how do we actually burn down that security backlog? All right. End of PowerPoint, thank goodness. All right. So I'm here in GitHub. I'm at the organization level here. So that name was kind of auto-generated from our demo generator. So the Crispy Octo Carnival is the organization that we have here. And there's 6 repositories in here. Again, we're not actually going to dive into too much code that's in these repos, but you can see there's a bunch of repos here. Again, there's only 6 here, but many of you probably have way more than 6 repositories in your GitHub organization. So we're going to talk a little bit about how we can secure at scale and some of the policies that we can do. All right, so let's start off with custom repo properties. All right, who's using custom properties for repositories in GitHub? Anyone? All right, so I'm going to go here to settings, and under repository, I'm going to click custom properties. All right, so anyone use topics for GitHub repos? Does anyone use GitHub repos? Okay, so if you look at a GitHub repo, let me just go to a public repo. I'll just go to AI inference. Let me see if I can find mine. Okay, so this is I don't even know if I've got topics on this one. All right, so here's a public repo. And for the public repo, you can set topics, right? I don't even know if I remember where to set topics. Anyway, so it was like little labels. So you could say this is Node.js or this is for Azure or whatever. You could set like a string, and that was topics. And then when you're searching for repos, either public or internal, you can search by that label. But the label is a little bit too basic because it's just one string. So what we introduced was something called properties, and the properties are a key and a value pair, right? So instead of just one label for a repo, you can set up a number of properties. So here we've got GitHub owner, for example, right? And so this is managed at the enterprise level. So this property would be, you can set this property on any repo in any org in this enterprise, right? So we've got that at the enterprise level. And there's a name and description here for the GitHub owner. So we can, if we've got automation for cleaning up repos, we know who owns the repo, for example. Here's another one where we've got a property called internet facing. And you can see that it's a true false. So we can mark some repositories that are internet facing true or internet facing false, right? Well, why would we want to do this? Well, first of all, we want to be able to group repositories, right? Because unlike Azure DevOps, where you have team projects, and you can kind of group repositories into team projects, GitHub has a very flat structure, right? So you've got the org, and then you've got the repos. So if you've got a whole bunch of teams all in the same organization in GitHub, how do you actually say these repos belong to team A and these repos belong to team B? Well, now you can do that with repo properties, and you can have a property called team, and you can define a set of values. So it could be team A, team B. So let's create a new property here for team. And the type, we'll make this a make it a single select. And we've got team A. And you can add descriptions here and so on, and team B. All right, so now when I create a repository, you can see how there's other settings here, require it for new repos. All right, so this is kind of metadata that you can set on the repository. Let's see if I can. Okay, we have to go through a lot of hoops to get authenticated. All right, so now I've got that new property. So let's go back to one of these repos. And let's go to this Code Security 3 repo. And again, I'll go to the settings, and we'll see the properties here. Custom properties. So you can see that unknown owns this particular repo. Right? Internet facing is set to true, and then the team, let's say this is owned by team B. So I can just set that property there. Again, that's nice because it's some metadata, but let's bring it back to how that relates to security configurations. All right, so again, I'm going to go back up to the organization level. Now I can set some settings on the repo level, but again, we want to talk about how we manage at scale. So how do we set policies, security policies, at the organization level that will apply to hundreds or even thousands of repositories? So again, I'll go to the settings page here at the org level, and we'll come down here to Advanced Security. And we have this concept called configurations. All right, so we can let's create a new configuration, and we'll call this Azure Dev Summit. All right, so that's our configuration. We can give it a description if we want. And now we get to choose what features of GitHub Advanced Security we want in this particular configuration. So we want secret scanning alerts. That's probably a good thing. We want to be alerted when there are secrets detected in the repository. And maybe we want push protection here, which I'll show. So that'll prevent a push with a secret from actually even getting to GitHub. Right? So we'll block on push. So we want that enabled. And then let's go to code scanning. Anyone using CodeQL, code scanning tool? All right, so a few hands there. So we can just enable the default setup, or we can enable with advanced setup. There's various options there, but let's just enable that. And then dependency graph, that's Dependabot. If we want to detect when we are bringing in vulnerable dependencies. And then we can decide whether we want to enforce this configuration. All right, so I'll save that configuration. I need a description. Azure Dev Summit. All right, so we'll save that config. All right, so now we have a new configuration. All right, so there's the Azure Dev Summit configuration. And now when I come here to the apply to, I've got an option. I can either apply it to all the repositories, right, or I can ring fence and apply it to certain sets of repositories. All right, so let's go and edit this. Oh, wait, that's the configuration. Hang on, let me get back. Where was my filter? Apply to. Okay, so that's all without configurations. Where is? Huh. This has gone and moved on me. All right, there is a way somewhere here. Maybe it's the enterprise configurations. All right, now I can't find it. There was a way to basically filter this to certain repositories by the custom property. All right, so I can't find that right now, so let me show you branch rules, because we can do that on rule sets for sure. Who's using rule sets here to enforce configurations? All right, so rule sets, again, are you setting that at the repository level or at the org level? Org level, okay. So again, let's do a new branch rule set where we want to enforce, let's just call this quality. All right, I'm going to set a bypass list here because I'm the only one doing this demo, right? But I'm going to allow myself to bypass that. Otherwise, you typically don't want to have too many people being able to bypass the security. And then here's the criteria where we want matching a filter. And in the filter here, this is where you can go to custom properties and internet facing equals true. So any repository that has the internet facing property set to the value true is going to then inherit this branch protection rule. All right, so if we create a new repo and it says internet facing is true, it will automatically have this branch rule set applied to it, right? So we can do that via the properties, and then we'll add the default branch. Right, you can also add feature branches or whatever other branches you're using if you're using different branching methodologies. And then there's rules around restrict creation. Maybe you want to enforce a naming convention on your repos. Well, you can enforce who can create those and who can create the branches. Let's go here to require a PR. Right, we want to make sure that people go through the PR process before they can merge in. And I'm also going to select this one here, automatically request Copilot code review. Who's using Copilot code review? All right, so a few hands here. So I'll show you some configurations that we can do there. But we want Copilot to automatically review all the PRs that get created. You can, of course, require code owners if you're using the code owners files. And then down here, we also want to require code scanning results. Right? So this is where we can enforce that every repo or every PR gets scanned and that we have a clean set of scans before we merge the PR. You can set here what level of alert you want to block on. All right, so in this case, high or higher is going to block the pull request from being able to merge. So you're going to have to fix those errors before you can merge. So let's create that. And now that has been applied. Yep, question there. Which tools can you add via add tools? Let me get down there. Okay, so in this case, I've only run CodeQL scans. But if you've got other tools like check marks or other scanning tools, we'll pick up that there are those other tools, and so you can enforce them. So in this case, I've only run CodeQL, but it should expand that list if you've got other code scanning tools. All right, we'll save those changes. All right, so let's just go back to, I want to go back to the configurations there. I'm not sure why I wasn't finding the setting for configurations by property, but that's all right. Where is Advanced Security? Configurations, and we want to make sure that everything's, okay, so this secure demo configuration is being applied. Now you can see that most of these options are not set. So I've got 5 repos. And in this particular configuration, most are not set. So let's actually, before I turn it on, I wanted to show you the coverage, right? So if I go to the security, actually it's under, it is under security. All right, so this is the security overview page. So again, this is at the org level. There's one at the enterprise level as well. And this is going to roll up all of the alerts, all of the configurations from all of the repos that are in that org or that enterprise. And so we can see an aggregated view here, right? So again, visibility across hundreds or even thousands of repos is non-trivial, especially when you've got a whole bunch of disparate tools. That team's using Fortify, and that team's using checkmarks, and that team's using CodeQL, and that team's using nothing. And how do you actually get visibility of what coverage you have, what alerts you have? So we have, I'll go to the coverage page. All right, and so you can see we've got code scanning is enabled on 83% of our repositories, but we don't have Dependabot or secret scanning enabled, right? So that's probably a bad thing, right? Yeah. But we can see here for each repo what is enabled and what is not enabled in the coverage. All right, and so if we want to improve that coverage, so let's go back to the configurations, security configurations. And I'm going to update the configuration. So let's go and edit this configuration. And you can see here we don't have secret scanning enabled. So I'm going to go and enable secret scanning on this particular configuration, which is going to apply to 5 of those repos. And we can set push protection as well. You can see the code scanning is enabled. And then again, the dependency scanning was not enabled. So let's go and enable dependency graph and enable security updates. All right, and now we have updated the policy. All right, so now we've one-click enabled that policy for 5 out of our 6 repos. Right, obviously could be all the repos. And if I go back to coverage, which is under security, and go back to coverage, okay, this might take a couple seconds to update, but we'll see this jump to 83% once all the initial scans have completed. So again, this is great if you're, it becomes less important if you're going to use the one click and just enable it everywhere. But if you're rolling out team by team or business unit by business unit, you may want to keep an eye on, okay, how many of our repos are we actually covering with GitHub Advanced Security? All right. I actually didn't define GitHub Advanced Security. For those that don't know about GitHub Advanced Security, so we have Dependabot, which is SCA, around dependency management. We've got code scanning, which is our SAST tool, that's actually scanning the code. And then we've got secret scanning. So those are the 3 primary kind of features of GitHub Advanced Security. And then we have all of the reporting and roll-ups and configurations built around that. All right, so Let's see what else we want to show here. All right, so let's go to a different repo. I want to go to this repo here. All right, and I want to go to the security tab. So this is what you would see on the security tab of a particular repo, right? So imagine I'm a developer working on this repo, and I go to code scanning, and I see that I have 14 alerts. All right, so one of the issues that we have with a lot of customers is, okay, which of those 14 should I fix as a developer? I mean, maybe the most critical ones. I mean, I'm an app developer. I'm not a security professional. So how do I know which ones are the worst ones or which ones I should focus on? So we'll come back and deal with that problem. But let's say that I want to fix this code injection here. All right, so they've got a code injection vulnerability. This is what the alert looks like. And you can see it says potential code injection in this branch, which may be controlled by external users. It's got a bunch of stuff there that maybe means something to me, but probably doesn't, right? But I'm going to hit the generate fix button, right? Who likes easy buttons to fix security vulnerabilities? All right, so that generate fix button is autofix. So now what we're doing is we're giving that alert to Copilot and saying, Copilot, give us a solution, give us a fix for this vulnerability. So that'll take a couple seconds to run, and it's going to come back with a suggestion of how to mitigate that vulnerability. All right, so that might take a minute or two. Actually, this one might not even be. We'll see what it comes up with. This is actually in actions, right? So CodeQL does actually scan actions as well. So we don't only keep your code safe, but also keep your actions safe. So I'm actually not sure what autofix is going to suggest here, but we'll give that a couple seconds. Sorry? Instead of the developer clicking, yes. Okay, so that's a great question. So the question was, is there a way to automate this instead of having to rely on the developer, go and click autofix? Can't we just automatically generate the fix for that? So this one, this is where I was talking about get clean and stay clean. All right, so this is a kind of the get clean motion, right? We turn on scanning, it finds a bunch of vulnerabilities that exist already, right? I'll show you campaigns shortly. The way that I would suggest you do it, and that's more on the stay clean, is when we enabled that code scanning must happen on the PR, when it is detected in the PR, it'll automatically suggest the fix in the PR, right? So you don't necessarily have to come and hit apply fix here. That's for existing alerts that are on your main branch. But for any PRs that are coming in, when you've enabled the code scan, whenever there's a detection, it will automatically suggest a fix in the PR. Yep. Okay, so let's see. I don't actually know if this one is going to... Oh, there we go. Okay. So we've refreshed. So now it's actually generated the fix for me. And you can see it says Copilot Autofix, and it gives me the explanation of what it did and what the suggested change was. And then I get this diff, so I can see exactly what code changes there are. All right. And then there's a commit to new branch button or commit to an existing branch, right? So I then get to commit this to a branch, make sure that it works, make sure that it passes all of my tests, make sure that the rescan works, all of that goodness, and then we can just merge that PR, all right? So that's autofix for existing vulnerabilities. All right, while I'm here, let me go and quickly create a new pull request. So I've got a couple of branches here. So I'm going to create a new pull request. And I want to use this add auto label action branch. All right, so I'm going to create the pull request. So that's got some code changes. And I want CodeQL to pick up issues with this PR. Spoiler alert, there are some issues with this one. All right, so we'll let that go. And then I have another branch here with some changes. Again, like the code, what code changes are there are not too important, but I've got this cart test branch, and I want to create a pull request, and so I want that scan to complete. So I'll create the pull request. It'll take a minute or two for it to run the code scans, right? So you'll see down here with the checks, there's all my CI/CD triggers that I've configured through my GitHub Actions workflows, but then you'll see CodeQL is doing that analysis. Where does that come from? Well, that came from the configuration where I said we need to go and scan all the repos using the standard configuration. So our standard configuration says this particular repo is Node.js and TypeScript, so those are supported languages. So it's going to run a Node.js and TypeScript scan. If this was Python or C#, it would apply whatever the language is. So I don't even have to build a workflow. I can customize the workflow and get a YAML file and customize what queries are run and do a whole bunch of advanced configuration, but I can just do it at the default configuration, and then it's applied en masse. All right, so that'll take a couple minutes. While that's going, let's go back up. Actually, it's the wrong one. Let's go back up here to the gas organization here, and we'll go to security. All right, so now you can see under code scanning, I have 31 alerts. Okay, now there's only 6 repositories here, so 31 alerts, 6 repositories is an average of about 5 alerts per repo. That's not too bad. But again, you can imagine if you've got 1,000 or 10,000 repos and each one has 100 alerts, right? That's going to be a lot of alerts that are aggregated here. And so again, how do we burn that backlog down, that security? Because this is essentially a security backlog. How do we burn that down? So we can create what's called campaigns. So I'll go to campaigns, and you can see I've got a SQL injection campaign here that's already running. All right, but I'll create a new campaign here, and we can create one from a couple of ways, but I'll create one from a template. So we have a number of templates for campaigns. So I created the SQL injection one before, but let's say I want to do a cross-site scripting campaign. All right, so I'll select that template, and you'll see that all it does is it's applying a filter for all the alerts. So I'm filtering anything where it's open. Auto fix is supported. That tells me that we know that Copilot's going to have a suggestion for that alert, right? Because it won't always have, but it'll have a lot. We have pretty high coverage for our alerts, but you can filter, right? So we're only going to create campaigns where there is an auto fix. And then you can see the external CWE 79, CWE 80, those are the CWEs for code injection. And so I'm able to filter down. Now, if I want to do some other campaign, I can make whatever query I want there, right? So you just twiddle the filter until you're happy with that filter. And we've got a nice little filter builder here, so you can set all the properties. It'll help you kind of build up that filter query. And then you can group it by repo. I like to group it by repo to see what the numbers are, right? Because 5 or 10 is probably okay. You probably don't want to create a campaign where a repo has like 100 alerts in the campaign. Because again, that's probably too much for a developer to deal with. All right, if your developers open up the campaign and there's 5 alerts, they can say, okay, I can deal with 5, right? If they open up and the campaign has 100 alerts, they're probably going to go, I haven't got time for this, right? So there's definitely sort of a psychological component to it. But this one looks okay, 5, 10, 5, and 1, all right? So let's go and save this. Now, you can save it as a draft campaign, or you can publish that campaign. I'll hit publish. All right, I'll choose an end date for that campaign. So let's say we give our teams 2 weeks to do that, so that it'll end on the 28th of October. And then I can create an issue, right? If I want to create an issue for tracking this, I can set campaign managers. I'll set myself as the campaign manager, but we might have other folks that are managing that particular campaign. And then if I've got a link for my internal documentation on how to fix a cross-site scripting vulnerability, why we think it's important that it should be fixed, whatever it is, I can put a link in there to whatever docs I want to provide, and I'll hit Publish Campaign. All right, so that will go and create the campaign in each of the repos, right? And you can see the PRs already starting to appear there. So let me go back to the SQL one. All right, so here's the SQL injection one that I created. And you can see that it says we have 9 days left until the end date. We have 0% of the fixes done. All right, so again, like now as the teams start to work on those particular fixes, we want to track how many have been fixed. Right, in this case, 0 have been fixed. All right, so now we can start targeting the teams to say, hey, you've got this campaign, make sure you put some eyes on it. But we can see these 3 security results from the Code Security 1 repo. So let's click into the Code Security 1 repo and see what that looks like on the repo itself. So now I'm in the repository, and on the security tab, you'll see that there are 2 tabs here. One was for the SQL injection one I created earlier, and then one is for the cross-site scripting one that I just created. So there may be multiple campaigns in flight. Again, like for best practices, you probably want to have a small number of campaigns in flight at any one time. But again, like there could be different teams working on different campaigns for different languages or different vulnerabilities. But let's go and click on the SQL injection one. So I get to see the same information that my admin does. All right, and then you can see the autofix pill there, right? So again, if we click over here, so this has automatically generated the autofix for us already. So even when I just open up the alert that's in the campaign, it's already got the fix suggestion there. It explains it to me. This is the database error. I can look at the paths, right? So I can see the path through the source code, right? So here's where it came in through the API login, was the entry point, and then it went through all of these methods, and eventually it ended up in the query down here, right? So that's how the data flowed, right? So if an attacker was trying to exploit this, I would see what the entry point is, see the flow all the way through to where it actually does the malicious query down on the database here. So that's the sink. So I can understand all of that. And then I can, again, commit to a new branch or commit to an existing branch. So I might want to group a couple of these fixes together onto a branch for that campaign. And then I can just submit the PR. All right, so let's commit this to a new branch. I'll just commit this one to a new branch. All right, alert autofix 10. All right, and then so it automatically creates the pull request, and you can see it's a potential fix 4 and goes back to the alert. All right, so it's all linked from the alert to the PR to the campaign. All right, so now if I go back up to the campaign, let's go back to security, to campaigns, and if I go and look at my SQL campaign now, you can see that we now are showing a bit of progress where we've created the PR, right? And so here you can see that there is a PR for that particular alert. So again, like security professionals are monitoring at this level, and they're seeing how many PRs are being generated by the teams in the campaign, and they can track the progress of that campaign. All right, so let's go back to our PRs that we created earlier. All right, so here was the auto label pull request. And I wanted to show this warning here called dependency review. All right, so what this has done is if we look at the changes for this particular PR, in this PR, it was creating an actions workflow. And this actions workflow is using this action called TJ action branch names. And that actually has a vulnerability in it. So again, like this, but this would apply to Python packages or NPM packages or .NET packages, whatever the dependency management system is that we support out of Dependabot. It would be the same experience. And we're saying, go and look at the changes that are being introduced in this PR and go and check if any of the dependencies that you're adding have any vulnerabilities. And so this particular PR has failed the dependency review because we're bringing in a package with a known vulnerability. All right, so that'll prevent the PR. The developer can go and fix this up. Now you can see, again, we give a suggestion here, and if I go scroll here, so it's saying that we should delete the 8.2. Let's see, did it actually give us the updated version? Okay, so it's saying it's not pinned to a commit hash, so we should probably find out what the commit hash is for that action and pin it to the commit hash. But again, if this was log4j 2.7 or whatever the log4j vulnerability was, it would say this is fixed in version 3 or whatever, right? So it would suggest the new package. All right, so that's the dependency review. And again, we'll just see here in the conversation here, you see that it failed for one vulnerable package. You may or may not see, I forget if this might be a universe announcement, so don't quote me on that, but you can see that we're also checking licenses. So who here says we never use MIT licenses, so we never use packages with MIT licenses or new licenses or whatever, right? So now we're adding in the actual license policies as well. So you can say fail dependencies if they have licenses that we disallow, all right? Let's go back to the other PR for the cart functionality. So I wanted to show a couple of things here. All right, so this one, the dependency review said, no, you're good. It did have a deprecation warning, all right, but we got a clean bill of health. And then over here, let me see if I can find a vulnerability. Actually, this one doesn't have a security vulnerability, but what I wanted to show you here was this comment here. You can see how Copilot said, ahoy. The JSON pars call me dangerous waters, all right? And let's look at another one here. It says, arr, ye be hard coding the free shipping threshold. All right, and this one, shiver me timbers, these product images be missing proper width and height. Okay, so it's clearly talking like a pirate. All right, so how did I do that? Well, let's go back to the code here. And I'll talk a bit more about this tomorrow, but anyone using instructions files for Copilots? Yes, all right, so you'll see here, I have this line of code here in my instructions files, all right? So saying always speak like a pirate, all right? So it's under a heading called front-end review guidance. Now, you don't have to have that heading there, but sometimes it's best with Copilot to be explicit. So this front-end instructions file, you can see it applies to certain folders within my application because this app has a front-end, a database, and an API. And so these instructions apply to when coding agent is working or when agent mode is working. I wanted to use this file because I've specified how I want my front end to be laid out, what components I'm using. But I'm also able to give it, when you're doing a review on any of the files matching those patterns, these are the things I want you to look for. Now, sometimes that's difficult to demo, so I just get it to talk like a pirate so that you can see that it's actually applying the instructions, right? But you would put real stuff in there, like I want you to make sure you check for this and this and this. So again, there might be quality things that you want to check, but your security professionals also probably want to collaborate with your developers. I'm like, maybe there's some security stuff we want to add in there to make sure that Copilot is adding those security checks into the code review. All right, so we've got the code review. Let's see what else we've got. All right, let's commit a secret to a branch. Let's live on the wild side, all right? So I'm going to check out, actually get branch, if I can type, branch-v, pat. Okay, there it is. All right, so get checkout pat. All right, so I've got this branch called pat, and I'm going to go to this README file here, where I have inserted a personal access token into the Markdown file. All right, so maybe I was testing some stuff, and I put a token into some file somewhere. It doesn't have to be a Markdown file, but whatever. It's in some file somewhere. I've committed that, and now I want to do, let's shrink this down a bit here so we've got a bit more space. So I'm going to do git push. To push that, of course, it's going to tell me I need to set the upstream. All right, and I am going to get a new, that is probably because I have already done this. Boring. Okay, so I was practicing this yesterday, and then I dismissed the alert, and so it's now it's not coming up. But maybe let me try a new one. Let's see what time we have. So let's create a new token. Hopefully this will work. Let's go developer settings, and I'll create a new token. Not going to give it any permissions. So this is ADS. Well, yeah, I mean, like it has to be a valid token, like because we'll check that it's actually a valid token. All right, so now I have a token in here. Let's see if I actually paste this in somewhere here. All right, so let's commit stuff. All right, and let's see if this push works now. All right, there we go. Okay, so you can see how it's actually failed the push. and it tells me that it found a GitHub personal access token, so we understand the format. We've got about 250 providers that we work with, so we understand Azure tokens and AWS and GCP and MailChimp and like all of these, Terraform, all of these kind of cloud providers. We understand all of their tokens. They give us their token formats, so we can code that in. So we know it's a GitHub personal access token based on the format. But you can see there is this URL here. So if I click onto that URL, I get the bypass page, right? Now you can also set that developers can't bypass this, but they can request a bypass that will send a notification to the admin, and the admin will review the bypass. So you can lock it down if you want to. But sometimes maybe it's a false positive, or maybe you're using it in tests. So that's all part of that push protection for our secrets. Yeah. So the bypass, let me see if I can get a good example. I believe there is on the secrets, it'll be under the security tab. I think there is another tab where you can see your bypass requests. I see this one I don't have. Let me go up to the org level. Secret scanning is a push protection bypass. Yeah, so this is where the alerts will come up to the admins so they can review those requests. So they'll be able to see all the requests that have been made for bypassing secrets. Right? Yep. Yep, and something that may or may not be new, which I can neither confirm nor deny, is here on the alert, the secret scanning alert. We actually also, for providers like Azure, we actually test the token. So if the token has already been deleted or invalidated, then we don't create the alert. Right? If it's a token that's no longer valid, then why would we put the alert up, right? But again, that's configurable, so you can actually determine, you can tell secret detection whether or not to test the token. All right, so that's part of the configuration. But over here under security, let's go to here. Let's go to this personal access token. There's this assignees that's new. All right, so you can actually assign, I want Joe to go and revolve this key or remediate the secret, right? So that's new. You can also see here in the code scanning alerts that this one was actually detected. If I can find it. Okay, so that was the README that it detected yesterday, right? So that's why I didn't bring it up again, is because I already had alert for that I bypassed as I was preparing, right? So that's why I had to create the new token, right? So you can see that even if it's an old token that you've already dismissed, then we're like, okay, well, you've already taken care of this token, so we don't need to keep reminding you about it, right? So trying to make the alerts actionable. Anyone using MCP? Anyone using the GitHub remote MCP? Okay, maybe a couple hands. All right, I wanted to show this. So for public repos, it's coming to private repos soon, but for public repos, we will do secret detection on the MCP calls to the public, to the GitHub remote MCP server. So let me start the server. That's the wrong one. All right, so here's my GitHub remote server. I want to make sure that it's started. All right, so it is running. All right, so I want to say here, add an issue called Pat with the body. And let's copy out that token again. All right, so here's the token. So we're putting that token in a call to the MCP server, right? Now I have to target a public repo. So in Colin Dembovsky / AI inference. All right, we're bringing it to private repos soon. There's issues about how we who do we attribute the secret scan to for our billing purposes? So hang on, let me retry that again. I might have to change the model. Seriously? Copilot's going to behave with me here. All right, so it's going to activate GitHub issue management tools. All right, so there's the MCP call. All right, and you can see it saying that that call was rejected because there were secrets in it, right? So the GitHub remote MCP server is doing secret scanning as well. All right. Let's see what else. Oh, okay, build attestation. All right, so let me finish off with this quickly before I take some questions. All right, so it's a colleague of mine called Ken, and he's got a repo that builds a Docker container. All right, so pretty standard stuff. I want to make sure that when I deploy this container to my AKS cluster or wherever I'm deploying it to, that it is actually a real Docker image that Ken built. I don't want anyone injecting malicious code in, right? And so what Ken did is on the actions workflow, he added this step in here, all right, called generate artifact attestation. All right, and there's a subject name and a subject digest, and there's this push to registry, so it's actually going to push that digest to the container registry. And that's all I need to do. So now I don't need to set up SIG stores, I don't need to sign certificates, I don't need to do any of that stuff. That action will do all of that. It'll use GitHub as the SIG store, as the certificate authority, and then what we can do is on the command line, you can use the GitHub CLI. Let's see if I can increase the font here a little bit. All right, so that's the format, GH attestation verify. You need to use OCI for containers, but this would work for any binary, right? So I can push an NPM package, I can just push a zip file, I can do attestations for any binary. The OCI is because it is a Docker image, and then I'm pointing to the repo and to the branch and to the image label, and then the repo, and then bundle from OCI. And then what that's going to do is it's going to download the manifest and the digest, and then it's going to validate and check the signatures. And in this case, the validation has succeeded, so I know that this image was built from that particular build. And you can expand out the attestations to make sure it was built from this build definition, and you can do all the kind of like usual attestation metadata, and then again we've got an admission controller for Kubernetes that will do that check, so that it'll validate the container images every time it's spinning up a new pod. All right, so that's build attestation. I think that was about all the demos I wanted to do. So we've got a few minutes for questions. Yeah, anyone got questions? Yeah. Do you want right in front here?
You go here.
Yes, thank you. So I was wondering, for the campaigns you were showing, once a campaign period has expired, how is it shown for those repositories that still have issues open?
Yeah, again, I think it's just a red warning. Okay. Like they'll just see it visually, and I think you can configure. I don't remember if you can configure it. I think they will get notifications. The repo admins will get notifications to say that there's a security campaign that's expired that still has open alerts. So there's some notifications for it, but I mean, we're not like blocking anything for that, but they will see it visually on the campaigns tab. Yep.
Okay, thanks.
All right.
CodeQL, is that yours?
CodeQL is from GitHub, yes. Yep.
And it just detects security, or does it do a general sort of code analysis?
Good question. All right, so CodeQL stands for Code Query Language, and it was actually an acquisition that GitHub/Microsoft did in I want to say it was 2018 or 2019. Yeah, 2019. There was a company called Semel. It was a sort of think tank out of Oxford in the UK. And so Semel created what it does is CodeQL will take the language constructs and it creates a database representation of the syntax trees, essentially, right? So it knows what the code looks like, and it puts it into a database that you can run queries over, right? And that's why it's called code query language. And there's a query language that you can build queries. We've built over the last 7 or 8 years a ton of security-focused queries. We're extending this out to do quality queries as well. So it's capable of doing any type of query, because once you've got the database, you can do all sorts of queries. You can work out cyclomatic complexity, or you can do a whole bunch of stuff. We focus all of our effort on the security space because we realize that it's a really great tool for very high quality results. So I wanted to show here, let me go to the SQL scanning one here. But if I go to the, let me go, this one does have a SQL. Let me go. All right, so here's the database query built from user-controlled sources. And let me get to the original alerts, if I can find the alert. Okay, yeah. So you see how this is JS SQL injection, and then it's got view source under the query. So if I click that view source, this will take me to the GitHub CodeQL repo. So we open source the query repo. So the scanning engine is proprietary, although you can, again, we publish it, so you can download and you can run the scan. Technically, you need a license to run the scan on private repos, right? So you need a GitHub Advanced Security license for that. But this is the actual query. So there's some metadata here around what this query does. There's the links to the CWEs that are covered in this query. And then you can see it kind of looks like SQL. There's a from statement, there's a where statement, there's a select statement, right? It's a little bit more complex than just plain SQL. It's definitely a little bit of a learning curve here. But we have a pretty extensive query library in this repo. So you shouldn't really have to build your own queries. But if you're a security professional, you can, of course, build your own queries. And then there's a lot of reuse here. Like this particular one actually, like this will detect if you're sanitizing the string, because normally you would say, oh, well, it's going to see, oh, I'm passing a string to the SQL query, so that must mean that it's vulnerable, right? But what if you've sanitized that string previously? So it actually understands how the code flows and how it works together. So the data flow that I showed you earlier, where it knew this is the entry point of the API, and these are all the methods, that's coming out of CodeQL, the data flow analysis. And so this query here might look fairly simple. I mean, what's it like, 15 lines of code? But it's actually doing a lot under the hood because it's bringing in additional libraries that are doing the whole sync and source thing and taint paths and all sorts of things. So there's a lot of complexity in here, so that we get high quality results, right? Because it's not just doing kind of like a regex, it's actually doing a bit more than that. Yep.
So is the plan to sort of get this to do, say, what SonarQube is doing, and a scanner like Aqua, like in one little package?
I can neither confirm nor deny
Okay.
that we are working on something which may or may not appear in 2 weeks' time. So look out at Universe, yes. Okay. Yep.
Maybe one short one.
Yeah, sorry, I was triggered by the gentleman's question. So I was wondering, is there something coming up like reachability? Because you have the SAST feature, you have the SCA feature.
Yeah.
Oh,
so we do have traceability for Python. I don't think we've got for Java. I think it was only Python. So we have some level of traceability, but there are other priorities. So technically we can do it, and we have some implementations of it, but we don't do the full traceability. Like for code scanning, we do. For dependency scanning, I think it's only on Python that we do the traceability. So when we detect there's a vulnerable package, you want to know, well, am I calling any of the vulnerable methods in the package? I think we only do that for Python. maybe. I forget. I've got to remember what our GitHub dependency traceability. Well, yeah. Again, like I think it's language dependent, so we'd have to look up exactly which ones dependency. Yeah, I'll have to look up exactly which languages we support the traceability for. But I know Python did it. I'm unsure about other languages.
And there's not a direct priority on it for the fact that that's coming in the next few months or something, or.
It's been coming for a while, so.
Okay. The reason I'm asking is that most dedicated AppSec companies that do SaaS and SCA have really focused on this in the
traceability
side, on the
yeah.
past few years, because it reduces a lot of noise and.
Yep. Yeah.
But it's okay.
I agree. No, I agree. I agree with you. Again, there's lots of things the security team's working on, so it's a matter of priorities for the team. So yeah. All right. Well, I'll hang around for a few more questions if anyone's got. But thank you. Enjoy the rest of Azure Dev Summit. Thank you.